Hey, welcome back to part 2 out of 5 in your velocity time graph series. In this video, we are going to look into what non-uniform motion looks like on velocity time graphs. In other words, what will acceleration look like on these graphs? So, before we do that, let's do a quick comparison between a position and a velocity time graph with acceleration using our moving man simulation. Okay, whoopsie daisy. Let's clear that. So, let's take a look at what happens if I give this man an acceleration. And let's just say I give him 1 meters per second squared of acceleration. See what that looks like. Okay, I'm going to play that. Okay, notice there's a few things. I'm going to stop before he crashes into the wall. On a position time graph, we've seen this before, a curve, a nice looking curve where the slope is constantly increasing, showing you an increase in velocity over time. And on a velocity time graph, it shows just that. Notice that your velocity is increasing as time goes on. Acceleration is just a flat line on roughly the 1 meters per second mark, but we can talk about that later. So notice that on the position time graph, a curve translates into a straight line on a velocity time graph. So that's the first thing we want to write down. The other thing I want us to notice is how I've given this man a positive acceleration, meaning he's going to gain velocity in the forward direction, showing that the line kind of looks like it's sloping upwards, or it's pointed upwards, so kind of like an upward slope. Now let's clear this and see what happens if I instead give him a negative acceleration. Okay, so the curve on your position time graph, and it's curving downwards, showing a decrease in velocity, sloping downwards. Just like on your velocity time graph, acceleration still remains to be close to -1 if you zoom in. But notice here that on your velocity time graph, the line is going downhill. It's a straight line going downhill when you have a negative acceleration. And all of these notes we're going to refer to velocity time graphs. So I'm just going to continue these notes here. The other thing I want to show us is what happens if we increase the acceleration. So let's say I give this 4 instead. Okay. Oh, that was loud. And then, so notice that we have a steeper slope on our velocity time graph. Okay, let's try that in the negative direction. And same thing, we have a steeper slope, regardless if it's going in the negative or positive direction. A larger acceleration gives us a steeper slope. Okay, so I'm just going to change up these notes so it's a little bit clearer. We're talking about velocity time graphs. Okay, so these are our observations. And so based on our observations, I want you to notice one thing is that on a velocity time graph, notice that the acceleration is described by the slope. So if you have a larger acceleration, and actually I need to change that, a larger magnitude of acceleration. That's only magnitude, because if it's negative acceleration, it means you have a smaller acceleration in terms of sheer value. Okay, so here we have the slope. A little bit, if we think about why it's the slope on a velocity time graph, I'm going to use this guy down here just to give us an example. So let's say we grab the slope here on our velocity time graph, and we know that the slope is the rise over run, okay? Now notice that the rise here means that we're looking at how much the velocity changes. Okay, so that's the change in velocity, and the run is how much time that we're looking at this change. So that's equal to time. So what's change in velocity over time? It's acceleration. Okay, And another thing I want you to note is that the units on the graph, so change in velocity is meters per seconds. And if we subtract, it's just like subtracting meters per seconds from meters per seconds, we still end up with meters per seconds. Time on the bottom is in seconds. If we divide meters per seconds over seconds, we get meters per second squared. So notice that we're not just randomly finding a value on the graph. It actually has significance. It actually means something. The units, the dimensions, all work out. Let's do an example here. For the following velocity time graph, let's practice finding the acceleration. So we're going to do the first one. I'm going to do the first one together, the first graph. Then I got a second graph for you to try afterwards. Okay, so let's start off with the first graph here. And first segment is from 0 to 8 seconds, so right there. Now take a look at this. The velocity here is constant. The slope is 0, which means we have 0 acceleration. That is just 0 meters per second squared. Easy so far. Now the second part, we will have to find a slope of this graph, just like I've been showing us earlier. So let's do this. We have a slope and it's positive, which is nice, always nice. And that's our rise over our run. Okay. Our rise is from 6 all the way to 9, 1, 2, 3. That is 3 meters per second for your velocity change over the course of, and notice in my x-axis, every box corresponds to 1 second. So I'm just going to count the boxes to give me seconds. 1, 2, 3, 4, 5, 6, 7, 8 seconds. And if we do that, if you don't trust my calculations, use a calculator. 0.375 meters per second squared. And for the purpose of just understanding this problem, I am not going to round it off, but you could if you want to. I don't really mind. To be technical, it would just be 1 sig fig, 0.4. Okay, but anyways, the important part is to develop these skills. Okay, now it is now your turn to try for this next graph. And notice that I didn't give you a lot of space for question A, so you might have to like do some job over here. Anyways, good time to pause, and I will see you back. Okay, now it's my turn to go over the problem. In the first segment, we have the time going all the way to 3 seconds, giving us a negative slope of negative 10 over 3 seconds, a run of 3 seconds. It gives us negative 3.3 continuous, but let's just run it up to 3.3 for simplicity. Next segment is positive slope, and I just chose a point at the origin to have good numbers. So we get 6 meters per second over 10 seconds, giving us a positive acceleration. Okay, so here we have it. The first segment, we have negative acceleration, and the second part, we have a positive acceleration for when the velocity changes in between in the 3 second mark. Now, I didn't really focus so much on just rounding and sig figs. On an actual problem, I probably would put more sig figs in the time so that it kind of tells you that, hints at you to round your numbers properly. But for the sake of practice, you can just leave your answers as such for this sake, okay? Well then, this concludes our part 2 of this video, which helps us look at what the slope on a velocity time graph is for non-uniform motion. Okay, so please stay tuned for part 3, which we will talk about more of non-uniform motion or when we have acceleration. So thank you for watching, and I will see you in part 3.